Did you know that strep is one of the only microbes with the ability to infect almost every part of the human body? You might know of it as strep throat, but when infections repeat, strep can trigger autoimmune diseases of the heart, kidneys, and brain, wherein the immune system attacks the body instead of strep. How strep infections result in this unexpected behavior of the immune system has baffled scientists for decades. On the left, you can see how immune cells detect harmful microbes to get rid of them. Hair-like proteins on the surface of these microbes help to serve as danger signals for immune cells. In turn, immune cells come and latch onto them. This interaction sets off a cascade of reactions that ultimately leads to the death of these microbes. However, that's not true for strep. Despite having a single hair-like protein on almost all of its surface, strep has a unique strategy to camouflage itself from the immune system. In my thesis, I show that strep sheds its hair-like protein. Using molecules that work like scissors, strep gives itself a haircut and chooses to go bald. And once I learned this, I wanted to find out how this haircut relates to the faulty immune system we observe during strep infections. To do that, I engineered strep to either keep its hair or lose it. So think hairy versus bald strep. Then I infected mice with these versions of strep to mimic a human-like strep infection. Also, remember that the bald strep keeps shedding its hair. It's not bald from the beginning. Okay, so what happened? In case of hairy strep, like I show you here, hair-like proteins help the immune cells to come and latch onto it and do the killing. However, in case of the bald strep, many more immune cells came in to fight the infection. Surprisingly though, these immune cells weren't good at killing. They hardly succeeded. What was happening is that strep was shedding its protein, hair-like protein, and so immune cells came in and were distracted by it. In a nutshell, I show you that the immune cells are hyperactive and can attack the body, and strep has successfully distracted the immune cells. To treat strep-induced autoimmune diseases, we cannot just target strep. Instead, we need to design or repurpose drugs that calm the immune system so that we can prevent the immune cells from being fooled by strep's haircut. Thank you.